All right. Hello, students. Welcome back to TutorHub, your e-classroom on YouTube. So today we'll be learning about oblique triangles, specifically the laws of sine and cosine. We'll have many techniques and tips on how you can solve this problem. So listen up and learn from today's video. But before we forget and before we proceed, please don't forget to subscribe to the channel, like the video, and leave your comments so that you'll continue to receive notifications whenever we upload new lectures in our YouTube channel. All right, so today our topic is all about oblique triangles. So what are oblique triangles? Oblique triangles are any triangles which does not have a right angle. Okay, so how do we illustrate this particular example? So in any triangle ABC with sides A, B, and C, opposite to angles A, B, and C, so angle side A is opposite to angle A, side B is opposite to angle B, and side C is opposite to angle C, right? So they correspond to each other. And if we illustrate our triangle, so the corners, right, the vertices of the triangle represents the angles of the triangle, whereas the opposite side of vertex A is side A, vertex B is side B, and vertex C is side C, right? And as you notice, there's no right angle within this particular triangle. So we call this an oblique triangle, okay? Right. So another illustration of an oblique triangle may look like this, right? Or this, right? So we can label that A, B, C, and C, and similarly A, B, and C, okay? So these are some of the ways on how we can draw oblique triangles. For as long as there is no right angle for that triangle, we call it oblique triangles. So there are laws in solving unknown values or unknown sides or angles within an oblique triangle. One of this is the law of sines, which can be represented through the following equations. Side A over sine of angle A is equal to side B over sine of angle B is equal to side C over sine of angle C. So do not forget that all sides are in the numerator while the sine of the angles are in the denominator. Okay? So don't forget that, and that these three ratios or these three quotients are equivalent to each other. So if, for example, we do not know C, we can use, and we know B, we can use this, and this would be our unknown. We can write that as X, and we can simply manipulate the equation, transpose it here to solve for our unknown X. Don't worry, we'll have more. We'll have examples when we go to our problem solving section, right? But at this point, I want you to take note and remember the law of sines, right? All right. There's also the law of cosines, which is a little bit more complicated, but I want you to look at the pattern, right? So the law of cosines is written as a squared equals b squared plus c squared minus 2bc multiplied by cosine a. So if you notice, if you have a squared isolated in the equation, you have angle A being operated using the cosine function, okay? If you have b squared here, you have cosine b operated here, and c squared, you'll have cosine c, okay? Now, if you have, then we already solved the mystery of the a squared, b squared, and c squared isolated from the rest of the equation, and we understand that whatever is on the whatever side is isolated on this side of the equation, that would be the corresponding angle would be taken and would be operated using the cosine function. Okay? Now, what happens to the other two sides? So you add the square of the other two sides and subtract 2 multiplied to those corresponding sides. So for example, you have a squared minus b squared plus c squared. Then you expect that b will be multiplied to 2 as well as c. So you have minus 2bc as your second term. In our next example, if you square a squared and c squared, you'll have negative 2 times a and c. Okay, if you have a squared plus b squared, you have negative 2 times a times b. Okay, so it's a little complicated, but if you understand the pattern, or if you see the pattern on how to write this equation, then you will find it much easier when we do problem solving later. Okay, so I want you to keep in mind the law of cosines and write this down in your respective notebooks. Okay. Now, these laws are usually used in solving problems involving oblique triangles, but also right triangles as well. But unlike right triangles, we can use Pythagorean theorem, the angle sum theorem, because you already know one angle, right? The 90-degree angle for right triangles, but it may be a little challenging for oblique triangles. So we particularly use the law of cosine and sine for these types of triangles, right? So our next question would be, when do we use the following laws, right? When do we use the law of cosine and the law of sines? So if you have one side and two angles given, okay, if you have one side and two angles given, we use the law of sines, right? Remember, you have A over sine A is equal to B over sine B, right? So if you have two angles and one side, then you can solve for this unknown side. Okay, so we use the law of sines for this particular example. Then, if you have two sides plus one included angle, then you use the law of cosines. Remember, a squared equals b squared plus c squared minus 2bc plus cosine a, right? So this is the included angle of the two sides, and therefore we can solve for the unknown side, okay? If you have three sides given to you, we'll use the law of cosines, and if you have two sides and non-included angle, we use either of the two, okay? So keep this in mind, write this in your notebook so that you will not forget. One side, two angles, law of sines, two sides, one included angle, law of cosines, three sides, law of cosines, and two sides and non-included angle. You can use either of the two laws, okay? I hope that's clear because we'll be having some examples in the following slide. So identify the law to be used for the given figure. So we have a guide here below for you to easily refer to. Okay, so you have this particular example. So you have triangle ABC, and you're given sides A and C and 25 degrees. So identifying this, we have side 1, side 2. So we have two sides and one included angle. An included angle is the angle that is between the two sides that you are referring to or you're considering. So which law do we use, right? Two sides plus included angle falls under condition 2. Therefore, which law do we use? Write in the comment section which law do we use for this particular example. Very good. We use the law of cosines. Okay. So that's the law of cosines. Then for the second example, you have still triangle ABC. So what information are given? We have side C and side A, right? And then we have a non-included angle which is 80 degrees. So by the way, which is the included angle in this particular example? Very good. The angle B is actually the included angle because it's between the two sides, right? So this is the included angle. Therefore, 80 is the non-included angle here. So which condition is depicted by this particular triangle? So you have two sides and non-included angle. Which one do we use? Which law do we use? Very good. So we can use the law of cosines or the law of sines. So we can use either of the two. Another example, you have another triangle ABC, and you have angle 92 degrees and 40 degrees, and you have side A. Which law would we use if we are given two angles and one side? Okay, which condition do we have here in this particular depicted triangle? Very good, it's under condition 1. Therefore, which law do we use? Very good. So we use the law of sines. Okay. So it's that easy how to determine the particular law that we use for a particular oblique triangle. So don't worry, students. We'll have more examples in the coming days. And I hope you learned something in this introductory video about oblique triangles and the law of cosines and sines. So don't forget to subscribe, like, and comment. And I hope you learned something for today. Thank you for tuning in to TutorHub, your e-classroom on YouTube. See you again next time. Happy learning, everyone.